rather than tell you too much more about my background, this is not about me, but I love the spatial industry. I started off making components for the spatial industry. When we talk about the spatial industry, or when we talk about Earth, or when we see an image of the Earth, the first organisation that I think of when I see an image of the Earth taken from way above, the first organisation I think of is NASA. And to me, NASA is probably one of the most exciting organisations on the planet, and I think everyone would agree when you remember that they put us in space, they put us on the moon. So NASA is integral to this industry, an absolute leader, and it's with great pleasure that I have the privilege of introducing our first speaker from NASA, Lawrence Friedl. Lawrence has an incredible list of achievements. His bio, all of the speakers' bios are on the website, and I'd encourage you, probably before the next session, if you haven't already read all of the bios, have a look and see at the calibre of the people who are going to be standing on this stage. Lawrence is our first speaker, and he's going to blow our minds with images of the Earth, which only an organisation like NASA at the moment can put together, but that's changing. So we'll be having a discussion afterwards. All our speakers will sit on the stage. We will be discussing their presentations together at the end of each session. So rather than introduce Lawrence too much further, Lawrence is currently the NASA leader and advocate for consuming earth science products. He's the author of a book called Earth as Art, and I'll let him explain why he sees the images that he sees as an art form as well as a spatial innovation. So without any further ado, would you please make welcome to the stage from NASA, Lawrence Friedl.
Great, thank you, Ruben. That's very, very nice to be here, and I really want to give thanks to SIBA as well as QUT for organizing this event. It's really, with spatial, really looking at the power of where and how spatial can contribute to the global challenges and sustainability issues and governance and policy. But really, maybe I can say on behalf of all the speakers, for an event that's focusing on where, we're really glad that you're here. And so one of the things I want to talk about is what are we seeing from space, and what is it that we're trying to, how do we know that, what are some of the things that we're seeing and some of the changes that are happening? But where we first want to start was a couple decades ago, and it's really, can we go to the next slide? Oh, sorry. There we go. There we go. And really, this is Earth's first selfie. Back in the late 1960s, it really was one of the images that helped open up this sort of collective consciousness and really getting the sense that we are all together on this planet. And what is some of the issues and leading to some of the issues related to sustainability sorts of things. And so within NASA, we've been looking, really looking at trying to get a sense from all these different perspectives. And so right now, if you jump ahead a couple decades, we now have 17 satellites that are looking back at the Earth, sort of doing these environmental selfies every day. And so NASA has really doubled down on spectra and the spectral aspects. And while some industries are really going for high spatial resolution, NASA's really just trying to exploit the spectral aspects of it. And so looking at things like passive microwave to look at precipitation and soil moisture, looking at scatterometry to do ocean winds and ocean wind direction and all, and speed. And a number of other sorts of methods, even gravity, looking at changes in gravity as a way of identifying changes in groundwater, which I'll show you in just a second. And it's really this effort to understand the Earth as a complete system. And it's looking at the oceans, the land, the atmosphere, the cryosphere, really trying to see how they connect up. But front and center, it really is the human aspect of it. And that's something that we're really seeing is changing in whether it's human behaviors and policies and all, that we're really seeing this being a key driver in some of the changes that we're all seeing. And so what we're able to do is take some of these images, put them all together. So this one is actually an image from a combination of fusion of images from many different satellites You can see on the land, it's looking quite a bit at vegetation issues as well as the snow. And then in the oceans, you're actually looking at chlorophyll, which is an indicator, a proxy for phytoplankton. And so you can sort of see the seasonal variations of it. And it's really looking at this Earth as a complete system that I think is really sort of one of the exciting parts. Because when we look at it from this repeated time frame, we can really see what those changes are. We can see what those variations, that can lead us to see some of what those trends are. And when we understand those in terms of developing the specific processes, that can feed into the models. And that's really the codification of our knowledge. And that allows us to do predictions. And we can really sort of see and do the what-if scenarios. Or actually what we can do is we can help other organizations, especially organizations in government and private sector who are making those sort of decisions and long-term planning investments. And this is sort of enabling for them. And so what we wanted to do in terms of looking at some of the changes that we're seeing, we wanted to start with forests. And really, this is a story that's more than just about forests. It's also a story about open data and open data policy, and it's also a story about governance. But what I want to start is with a man named Matt Hansen. Now, Matt Hansen is really tall, really thin, and really strong. And so he reminds me of a tree. So this is the reason why, there's a good reason why this guy studies forests. And so he studied, he worked with, under some government funding, he worked with the Moore Foundation and especially with Google Earth Engine to take the archive of Landsat data that USGS had opened up. And through Google Earth Engine, they had compiled it going back to 2000. So we're talking trillions of pixels that they were able to do. And so this is a Landsat image. If you're familiar with Landsat, it spans 5, 4, and 3. And so the forests are in green, the sort of soils are in the mauve color. And he went back to 2000 as the baseline to try and see what can we see about changes in forest. Where are their gains, where are their losses? And he brings it up to 2013. And so I want to show you next is these are the changes. And so you can see the numbers, he's done it by year. And so the yellows are back in 2000 and the reds are up to the 2013 timeframe. And when you look at it, you sort of see changes in different parts of the world. When you add this all up, in 2013, it was about 18 million hectares. That's the size of Uruguay or Cambodia. And we've had that change, just about that change, going back to 2000. So every year from 2000 to 2013, we've been losing forests about the size of Uruguay. When you add that all up over 10 years, that's the size of Queensland. And so it's dramatic when you get to it from the global sense of just how much we've been losing forests. But I want to bring it down to this local level, or a little bit more the regional level. So we're looking at the Ivory Coast in Liberia. And this is where it gets into a little bit more of an issue of governance. And so here we're looking at the same bands, Landsat 5, 4, and 3, same with forests and vegetation are in green, soils are more in the mauve. What I want to do is show you where the changes have been. And so this is, you can see that in the red, this is where the changes are. You can see a little bit in the purples and blue in terms of whether there's been loss and gain. But primarily, we're seeing mostly it's these key losses. Now what I want to do is lay over where the boundaries for protected areas are. These are national parks, national forests, and other things, essentially protected areas. And so if we look at that, we see a couple different items. One, we really need to praise Liberia for some of the things that they've done from a governance standpoint to really protect the areas that they've set aside as parks and protected areas. So first of all, we really need to praise Liberia for what they've done. On the Ivory Coast, it's a different story. Now in this time frame, they've had 2 civil wars. And civil war essentially means loss of governance. And so you can imagine people who are struggling for their livelihoods are going to be going into some of those protected areas, and maybe you can't blame them because they needed food and fuel for their families and loved ones. At the same time, it really sort of points to this breakdown of governance and how important it is for governance to provide for some of the sustainability sorts of issues. So if you're going to be talking about forest, we think a lot about CO2. And so now we want to show, thanks to our colleagues at NOAA, a way of looking at CO2 levels that have been increasing over time. And so on the left-hand side, you can see the parts per million in terms of carbon dioxide in the atmosphere. And along the bottom, you can see the latitude. And so on the left-hand side is station in Antarctica, McMurdo Station. The one in red is in Hawaii, Mauna Loa. And essentially, you can see some of the other ones are just different stations that have maybe not taken measurements as long, but when you do the collective sense. Now, we're going to see a whole bunch of variations on this. And you're going to see variations, so we're going to run it from 1979 up until about 2013, I think. And we're going to see some different variations, and so just sit back and sort of enjoy and watch. So you can see sort of in the northern hemisphere, there's this really wild fluctuation, some of the seasonals up and down. But then you move over to the McMurdo Station in Antarctica, and you can sort of see this steady climb. And one thing this points out is something we all know is just, what comes around goes around, and the fact that it's all one complete system. And so that we may not have a whole lot of sources of carbon dioxide in Antarctica. You really sort of see that this mixing of the atmosphere is creating and spreading the CO2 all over. So this is just one way to sort of visualize the increase in CO2 that we have. What I wanted to do is actually point to another way of looking at it. And this is where, can we go to the next slide? There we go. And so we're about to play a video, but I wanted to set a context first. Here we did a model. So some of the NASA scientists, and they just recently updated it late last year. And so this is another way of sort of looking at the services, what they call ecosystem services that the forests are doing, the forests and plant life and the oceans and all are doing for humanity. As we continue to pump a lot of CO2, especially the northern hemisphere, a lot of CO2, it's really these plants that are doing the service to suck it up. But I wanted to point out, in terms of where on the year. So the whole video is quite long, so we've just condensed it from the beginning of May until the very end of July. Now, in the northern hemisphere, obviously spring and the growth and the buildup begins at about March, April timeframe, but still it's May, and you can see that the red, which is representing the higher concentrations of CO2, are quite present. Now, there are some issues in terms of down below, and you can see white in terms of the carbon monoxide. That's a different story for another time, but right now we're just looking at the carbon dioxide. So we'll play this for a little while. And you can see down the lower right what we are. We're sort of just the first week in May. You can barely even make out the continents up north. Maybe you can see a little bit of that yellow-blue area. That's Greenland. You might be able to see the west coast of North America. You can see certainly a lot of CO2 coming out of the city centers. Eventually, we're going to see where, because of photosynthesis, where all of this CO2 gets sucked up by the vegetation. It's starting to happen now, and here we are in mid-June. But still, it's sort of swirling around. We still got a lot of biomass burning there in Central America, also some in Southeast Asia. The white parts in Africa, that really is sort of biomass burning, and that's where the carbon monoxide is coming from. So here we are the first week in July, and we're really starting to see some of the clearing in the northern latitudes. Again, this is sort of the sucking up of carbon dioxide that the plants are giving us. And so it's something we knew, but this is a way of helping us understand, well, where is that onset? And just a spectacular way of understanding the service that they're providing. So we've gotten to the end, and so we wanted to jump into now is the Arctic sea level, the Arctic sea ice, and just the dramatic declines that we've been seeing in it. And so it's starting out in the early 1980s, and it's going along, and we're going to see a really rapid decline at about 2005, and that's one of the things we've been seeing. So what we've done is we've plotted for every year since about 1980. We've plotted essentially the lowest area of that sea ice. And because of our satellites are going around the poles, when most of their satellites are going around the poles, we got a lot of images of the North and South Pole. And so we're really able to see. And so it's really interesting that even the local maximum here in the 2013 timeframe is still well below where we were 2 or 3 decades ago. So if we want to move on from this, we actually want to move over to another story, which is actually maybe a bit more positive. And here we're talking about nitrogen dioxide. So nitrogen dioxide is more of an air pollutant. It's actually created from combustion. So you think about power plants, you think about cars and trucks and all. And it's actually leading to a lot of health effects, and so adverse health effects. And so on the one hand, it's a proxy for human activity, but it's also a way of understanding just what the exposure is. Now, in the mid-2000s, the US put together some regulations and put some new regulations in place to try and improve air quality. And what this is showing is the satellites, and this instrument was actually from a Dutch organization. So thanks to the Netherlands for building such a great instrument that's flying on the Aura satellite. Really it helps us see from 2005 to 2011, and it's continuing on, the improvements that have occurred in the air quality conditions. And so you can sort of see, if higher concentrations of nitrogen dioxide are in red, you can sort of see the difference between 2005 and 2011. And the point really is the fact that the satellite observations, the spatial component, really helps us, or helps government and helps the public understand and track the progress towards these policy objectives. And if we need to make mid-course corrections, we can. So that's one of the powers of spatial and geospatial and Earth observations, is helping us track progress towards these policy objectives. Now, certainly in the right-hand image, there's still a lot of red, and when you look across the entire United States, there's still about 140 million people that are in areas where they're not meeting the air quality standards. And we certainly know there's other parts of the world where air quality is a lot worse than this. But how is it that we can be using these observations to help point out and to help encourage policies and the implementation of policies that can provide these beneficial health effects? One of the things we talk about when we talk about the changing climate is water. And that's one of the big concerns in terms of, certainly the Earth has plenty of water. Most of it is salty, though. So our big concern is fresh water. Where is it? Where is it going to be? And under changing climates, where is it going to be? Where do we need it, and where might it be falling? One of the big issues also is trying to understand groundwater. And so during drought times, people oftentimes go to groundwater to help irrigate their fields. That's certainly what we're doing here in California. And so when you look back over the last 12, 13 years, there's really been this dramatic decline. There's been several droughts. Obviously, we're in the middle of a big one in California right now. And so we've been drawing down the groundwater in order to irrigate our fields and to maintain livelihoods and help people eat. But you can see here in terms of this change from 2002 up to 2014, and believe me, it's gotten even worse this year because we continued into drought conditions. We're just not getting the snows. And so we're draining it. So you can sort of see this is actually we're able to determine by changes in mass. So when you look at a pair of different satellites that we have up on orbit, you can, based on their variations in their distance between them, you can determine the mass underneath. And what we're really understanding is the fact that we can see these changes both seasonally. So like in the Amazon, you can sort of see the moving around of water from a seasonal standpoint, but you can also see these changes in groundwater from an annual standpoint. And that's really based on people drawing the groundwater from these aquifers. So here it is in California. I next want to show you where it is, what's happening in Pakistan and India. And so this is going from 2002 to about 2008. And there were some policies in place from the Indian government to encourage the use of groundwater to do the irrigation. But the effect is the fact that they're draining that faster than it can be recharging. And so you can see here just in that 6 years, just this dramatic decline, and not just in the colors. I mean, this is we're talking. I think it was something like 88 million gallons, or even more than that. Anyway, it was a large number in terms of just drawing this down. Now, just a week ago, some NASA researchers came out with an examination of 37 of the major basins and the major aquifers around the world, using the same technique in terms of using gravity to look at what the conditions of the aquifers were. And so you can see that some, Some more in the reds, and the reds and yellows and oranges, have really been losing. There are some aquifers, though, that are quite well along in terms of the blues. Of the 37, 21 were sort of seen to be stressed, and 13 overall were sort of at this point where they were, unsustainably being drawn down. In Australia, it looks like there's got 2. In the Canning Basin in the northwest, number 37, is one that actually is one of the ones that was in the stress list, whereas the Great Artesian Basin on the right-hand side looks like it's doing fairly well. So we can certainly refer you to that if you're looking at more of this. But if we're going to be talking about water, we also are going to be talking about sort of food. Obviously, there's a big nexus between those two. And so one of the things we sort of know when we're able to tell from looking at the world from space is where the major croplands are. And so you can see here, you can see where these croplands are. And if we take essentially the countries that are associated with them, we can hit it one more. We can sort of see that there are 26 countries that are the major producers, or the producers for 4 major crops: maize, rice, soybeans, and wheat. And we can map over that in terms of where the population are. In some places, it matches up. And so these countries are sort of the main, exporters of food to different places. And certainly there's growing that goes on, agriculture that goes on everywhere. I mean, certainly in Central Africa and Sub-Saharan Africa, there's certainly plenty of agriculture going on, and sometimes it's subsistence farming. But when we're looking at the major ones, there's 26 countries that are producing 80 to 90% of these global food production. But when we look at the population, we sort of see that the countries are expected to double. And so this is one of the issues related to food security and food resilience that we're really sort of looking at. So when we, through the Group on Earth observations, this international Group on Earth observations, set out years ago to try and understand what is it that we can do from the satellite observations to give a sense in season of what the crop conditions were. One of the things that the economists have been saying is that price volatility is often linked with food insecurity. And so what we're trying to do is use the power of the observations from space and provide it in a transparent way so that in season we can understand whether a crop in a certain part of the country, or a certain part of the world rather, is having a bumper crop or whether it's going to be struggling. And so in 2002, we have this product from 2002, it's this map. If you remember, there were some droughts in Ukraine and Russia and certainly in the US. And so what we can do is we can compare the current conditions using something called the Normalized Difference Vegetation Index, NDVI. Essentially, it's a way of using satellite data to determine what's the rigor and health of crops. And so we can compare the current conditions to what the average is. And so here you can see in central United States as well as in Ukraine and in Russia that the browns are sort of showing that compared to the average, 2012 was was doing worse than normal. Now in Canada and in China, you actually see some green areas, so they actually had a little bit better year. And so it's a matter of proving this out and sort of using the satellite observations in season so we can give this information to ag economists and traders and policy analysts so they can help fluctuate, and we can provide this information into the global food production system so people can understand and have more lead time in terms of where they may need to move food around. And so this relates, it's actually a year before that, before these big droughts, when we were discussing this with the G20 agricultural ministers about the value that these observations could provide to provide these in-season estimates of agricultural production and the crop conditions. And working with them throughout, that led into actually the G20 ministers at their meeting in France, in Cannes, France, essentially to create this initiative to use the satellite data to inform the Agricultural Monitoring Information Service. And that AMIS is the one that gives out this information on a monthly basis in terms of the crop conditions. Now, it's not a matter of us asking people to become remote sensing experts and try to interpret these images. What we did actually was we worked with graphic designers to understand how is it that we can help translate this information into ways that's easily accessible by policy analysts and economists and traders and all that. And so I think that's a big issue, is also how do we take the elements of design and graphic design and build that into our products to help that information transfer, that knowledge transfer, essentially that technology transfer. And so that's one of the things they did here in terms of putting it in simple colors, putting in simple icons so that people could quickly assess this. And so this comes out on a monthly basis for those 4 major crops that I talked about. And so Amos puts it out, and it's transparent, it's open to everyone. And along with this image, there's actually 2 or 3 pages write-ups for the global crop conditions for all these crops. I wanted to talk briefly about the Sustainable Development Goals. If you're not familiar with these are the follow-on to the Millennium Development Goals that went from 2000 to 2015. And so at the end of September, the United Nations General Assembly is going to be adopting these 17 goals and the 167 targets that are associated with them. And they're covering things like hunger and food security, water availability and water resources and water for hygiene, looking at urban development issues, looking at education, looking at oceans and forests and deforestation types of things, many and across many different issues. Now, in a quick assessment of these 17, we identified that at least 14 of them have some relationship to spatial, geospatial, or Earth observations. And really the big issue right now are the indicators that are getting developed that are going to be used to track the targets and the goals. It's those indicators that's going to be providing the way that the countries communicate how they're doing towards these goals and how they're doing towards the targets. And I think that's the real opportunity that we have in this community here. And so I have a favor to ask, and also I would say that if you take nothing away from my talk except for this one point, this is it. The United Nations Statistical Division is the one who's sort of helping set up and lead the effort with the nations, obviously, to determine what these indicators are. And the United Nations Statistics Division is used to doing household surveys and all. I think the key opportunity is for us to work with them to help them understand where spatial data, geospatial information, Earth observations can help feed into these indicators. One is just from the humanitarian efforts that we can help contribute this perspective to lead towards these goals, these noble goals. But you might also think about it in terms of we can get these into the indicators and these countries use it for the next 15 years. That'll be quite habit forming if you get my drift in terms of a nice way for them to integrate that and continue to use geospatial and spatial perspectives. And so really my favor is for you all, either at a break or at lunch or this evening or something, to try and find out who are the person or persons in your own countries that are working with the UN Statistics Division to develop these indicators, and talk to those people and help encourage them to be incorporating spatial, geospatial, and Earth observations information into this indicator set. I really think it'll go a long way. And so if there is some sort of skepticism that you ever get, let's remember the Montreal Protocol. And so people are skeptical in terms of, can we really even use geospatial and these perspectives to help drive these changes in human behavior? I think it is the sort of Montreal Protocol, which is the poster child for showing that humanity can act. And so here we're sort of showing the changes that are occurring from the 1979, and we're just starting to see now in the southern hemisphere in the Arctic ozone hole, we're just starting to see some flattening out. In the mid-latitudes in the Arctic, in about 2040, the predictions are that we're going to see the sort of recovery. It's going to be a little bit later here in the Antarctic ozone hole, but we are seeing this. But one thing that we did recently, some of the NASA scientists did, was try to predict what's the world that we avoided. And so we modeled out. And so on the left-hand side here, no, I should say this. Throughout the day, throughout the presentation, I've sort of been showing, blues to reds. And before, red was really bad. Nitrogen dioxide levels or CO2 levels in red seem to be really bad. Here, I want to point out that ozone in the stratosphere, higher numbers is good. And so here what we want is we want the oranges and reds because that's showing a recovery of the ozone hole. And blue is actually bad when it comes to, so we want higher numbers when it comes to ozone in the stratosphere. And so what we did is we looked at in the left-hand side, you're going to see this is the pathway that we're on. And on the lower right is actually the world that we avoided. We essentially took the trends that were occurring before the Montreal Protocol was in place and just continued them on and to sort of see. So let's run this and we can get a sense. And so up and through the mid-1980s, things are about the same, starting to do a little bit of a diversion. Growing a little bit more in the 1990s. Here we've just about doubled the chlorine levels in, 2008 or so. Here we are today, essentially 2015, you're starting to see almost permanent blue in the Antarctic ozone hole. And here's where it gets really interesting. Getting up at about this time, you sort of see that 2030, 2040 time frame, you're sort of seeing that we've actually dropped below into this blue region where we've actually got this global ozone hole. And so when this runs out, I think it's about 2065 when it runs out, you can essentially see this is the world that we've avoided because we acted. And so you can imagine if you've got what in Australia, you've got this slip, slap, slop. You can imagine that's what we're doing right now. You can imagine, can we get SPF 30,000 for this world? And so with that, I wanted to close on sort of an Australian selfie. And just sort of reflect on the fact that one of the things we were trying to get across here is that we can use these Earth observations to identify what are some of these trends so that we can help government and help the public sort of take action and to implement some of these policies that they're going to be helpful and for sustainability sorts of issues. But we can also use these observations to help track what is the progress towards some of these policy objectives. We might be able, through crowdsourcing and all, to use these Earth observations as watchdogs to help organizations do the right thing. And so is it essential, can we use these observations to praise the Liberias for what the progress that they've had, but can we also use it in the Sustainable Development Goals to help the citizens put the pressure on the countries to help make progress towards those goals? Can spatial and geospatial and Earth observations play those roles? But I think the other thing is the value that's been in an open data policy. And that a lot of these things have occurred and a lot of the innovations that have occurred is because this information, this data has been freely available. And it's led to some really innovative uses, both in the scientific as well as sort of the industrial and application realm. And so with that, hopefully we've sort of seen that there's all these ways that Earth science can serve society and that we've really made these opportunities, and it's really been this chance for space and spatial to serve the Earth. So thank you very much.
Thank you very much.